Welcome to Pradeep sir classes as PSC where logo can talk the physics. And today students we are in a classic text series that is it will be day 4 and you have to follow it serially. So this is Irodov solutions and today's we are discussing about 3.9 as well as it if it possible because each and every numerical can empower and it is too much lengthy uh, because each and every numerical consists of a large number of views, large number of concepts and clear your views with a greater extent. Okay, so students, first of all, let's try with 3.9 and if it's possible then this is 3.10. So this is electrodynamics and so let's with 3.9. So students, first of all, write down the question, that is 3.9, and the question is a thin wire ring of radius r carries a charge. So this is a wire ring and the radius is r and carries a charge q Find the magnitude of the electric field strength on the axis of the ring as a function of distance L from its center. So you have to calculate electric field here as a function of L. From this, and investigate the obtained function as L is greater of R. Find the maximum strength of the magnitude and the corresponding distance L and draw the approximate plot of the function. So it is a function. So first of all, students, you have to calculate electric field here, and a charge of Q is uniformly distributed over the ring. So there is a ring. Suppose you can think as this is a ring and you have to calculate electric field here, that is on the axis. So it is a three-dimensional configuration. It is written as, if it is two-dimensional then it is written as this one, and if it is 3D then written as like that. So this is a ring and you have to calculate electric field on the axis, that is L distance from its center. So first of all, students, take a small elementary distribution of charge here. So all the charges are distributed over the ring, and first of all choose a small portion of it, that is dl, and it contains dq, a charge of dq. A small value of elementary consideration contains dq amount of charge. So this, due to this dq, electric field is along this direction. Obviously it is dE, since the charge is dq, then the electric field is dE, and this is r is given, this is r, so this is r, this is L, and you can easily calculate the value of this hypotenuse, that is r square plus L square. Is it clear or not? I think it is a clear one. So dE equal to, due to a point charge, electric field, we know that E equal to 1 by 4 pi epsilon naught and Q by R square, where R is the distance from the charge. If it is a charge and this is the distance, then the electric field at that particular point, you can calculate with the help of this equation, equal to 1 by 4 pi epsilon naught Q by R square. So here you can write 1 by 4 pi epsilon naught and then charge, that is dq, by r square. So this is the square. So r square plus L square, and since this is a root, then this is square, means r square plus L square. So dE equal to this one, and if we students take this is as theta, then we can easily resolute the component of electric field along this direction. So this is dE cos theta. So this is DE cos theta. And students, since this is DE cos theta, so we can write take another component here, that is DE sin theta. Okay, I think it is clear your concepts. Okay, similarly, if we take another component over here, this is the, we can take as the symmetrical point, that is mirror symmetry, so dq, and this is also dq, so this is dq, and the electric field due to this small amount of charge, that is also dE here, and since this is theta, so this is also dE sin theta. Okay, dE sin theta, and along this direction it is dE cos theta. dE cos theta. So this is the normal component of electric field. So these and this one cancel, and all the electric field comes out due to this component. Similarly, if you take here the small component and at that point another component, then always you have to add up all the cos component along this direction. So we can say that the normal component of electric field is equal to integration of dE cos theta. dE cos theta. So cos theta, and cos theta, you have to add up all the integration. So this is dE cos theta, and what is the value of this one? So this is 4 pi epsilon naught dq by r square plus l square, and the cos theta. What is about cos theta? So cos theta, since this is theta, so this is perpendicular and this is base, so L by this one. So you can write L by root over of r square plus L square. And the students, if I take this is as a proportionally constant, there is kappa. So kappa, it is Coulomb's proportionality constant. So kappa, and this is dq, here it is integration, so L by root over of r square plus L square, and this is 1 and this is half, so this is 1 and half means 3 by 2. 1 and half, this is 3 by 2, and then remain the integration of dq. So integration of dq, students, you can easily say that this is q. So E normal component, and this is equal to 1 by 4 pi epsilon naught and QL by r square plus L square and whole to the power of 3 by 2. 1 by 4 pi epsilon naught L integration, this is QL, r square, L square, 3 by 2. So this is the value of electric field intensity at that point, that is along the axis. So there is a ring and you have to calculate electric field over here, and all the dq, that is Q, can create an electric field intensity along these directions, okay, of amount this one. So the first answer is a thin wire of ring is given. Find the magnitude of electric field strength on the axis of the ring as a function of L. So it is a function of L. Okay. So it is a function of L, and investigate the obtained function at L is greater R. L is greater of R. And find the maximum strength of the magnitude and the corresponding distance L. So students, next one is you have to calculate the maximum value. So students, next one is you have to investigate this particular one. So the investigation. What is about investigation? That is, this is greater. L is greater of this radius. So you have to calculate electric field over here, and this one. That is the large distance from the center. So when L is greater of R, then you can say that R is a very small and square of this very small value is negligible. Negligible. Okay. So this is a negligible quantity, then you can say that En equal to 1 by 4 pi epsilon naught and QL div upon L square to the power 3. So 2 and 2 cancel this one, so this is the L cube, or you can easily say that 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught and Q by L square. So this is 1. Students, think about it. Suppose there is a charge of Q here, there is a charge Q here, and you have to calculate electric field at a large distance from this charge 1, this point charge. Then suppose this is the length of L, and at the electric field at that point is 1 by Q by R square. So these total charge that is distributed over the ring can considered as a point charge, and this is situated at this point, and you can easily calculate the electric field at a large distance from L. So when there is a ring and you go from that particular ring at a large distance apart, then you can see that particular ring is a point charge. And what is the intensity at the large distance due to this point charge? That is 1 by 4 pi epsilon naught Q by L square. So this is the investigation. And the next part is, and the next one is, if the length L is 0, so you have to put here L is 0, then you can think the electric field is also 0. So what is the intensity of electric field over here? This is 0. Since L is 0, so L is 0, then the electric field at that point is 0. And again students, if you take L as infinite distance apart, then easily you can see that the electric field is again 0. So electric field is 0 here, and at infinity the electric field is 0. So you can easily think that somewhere the intensity is maximum. Electric field at the positive infinity, it is equal to 0, and the electric field is here is also 0. So there is electric intensity at that point, and that point, and so on. Within the pathway between the center and the infinity, the electric field is somewhere there is an electric field of maximum value. So you have to calculate where the electric field is a maximum value, can possess a maximum value. So since this is a function, so you can easily show that by taking the first order derivative, and this is equal to 0, you can calculate the value of maximum electrical intensity. So electrical intensity, suppose you can follow the different concepts I given, and again explain that particular one, that is the concepts of maxima and minima. Suppose students, this is a curve, and here the value is minimum, here the value is minimum, and this is the point where the intensity is maximum. So at that point the slope is a positive one, and if we take here the slope is negative. So this is a negative slope and this is a positive slope. So somewhere the electric field is, the slope is 0. So this is the electric field is 0, and at that point the electrical intensity is again 0, but at the previous one the electric is negative and that one is positive. So what is about where the intensity is 0, then we can easily say that this is the point where the electrical intensity is 0. So at that point the differentiation is 0. So the slope is 0 means there is no, that is the first order derivative is 0, and we can easily show that, and the intensity at that point is maximum, where the slope is 0, possesses a 0 value. So you have to take this is as the first order derivative and equal to 0. We can easily show that where the electric field is maximum value. So this is the 0 point. At infinity this is also 0. So somewhere between the 0 and infinity there is a point where the electrical field intensity is maximum. And also students, you have to consider the changes, the nature of the slope, the changes of the nature of the slope, and then you have to take the second order derivative. So students, if the concepts of derivative is not clear, then for that particular numerical you have to know maxima minima as well as the first order derivative, the second order derivative, and the conditions of slope that is always changing with a particular function. Okay, so the next one is you have to take the derivative of first order, and this is equal to 0. So dE normal component divided by dl, and this is equal to q upon 4 pi epsilon naught, and this is dtl of this one. So this is L divided by r square plus L square and whole to the power of 3 by 2, whole to the power of 3 by 2. So what is about differentiation? So this is equal to 0, and so this amount is also 0, so 0 equal to this one. So u by v method, and again I repeat the method, v du by dx minus u dv by dx divided by v square. So this is the formation of the concepts related with when the function is remain like a quotient form. So this is u by v method, u by v. So you have to take this one as, then you have to take the derivative of this one, and again this one by v square. So what is the derivative of this one? So the derivative of this one is r square, then take L square whole to the power of 3 by 2, and the differentiation of L. So ddl, dl by dl, that is 1. So this is 1 minus, and then minus, and take this one and then derivative of this one. So the derivative of this one is 3 by 2, and then r square plus L square whole to the power of 3 by 2 minus 1. So 3 by 2 minus 1 means half, and then differentiation of L square, that is equal to 2L, that is equal to 2L. So students, I repeat this one again. So this is 0 equal to dTL of this one. So r square plus L square whole to the power of 3 by 2, and the differentiation of L is 1 minus 1. So 1 and L is similar. You have to think this is a similar alphabets like that. So this is whole to the power 2, and the dl of L, this is 1, and then the L, and then take the derivative of this one. So this is 3 by 2, and r square plus L square whole to the power 3 by 2 minus 1, that is half. 3 by 2 minus 1, that is half, into the differentiation of 2L divided by r square plus L square whole to the power of 3 by 2 square, that is cube. And this one, when 0 by something, that is equal to 0. So this is we can erase that particular one. We can erase that particular one. So this is, so r square plus L square, and then take as 3 by 2 minus of 2 to cancel this one. So L and L, this is also L square, and then 3 and r square plus of L square whole to the power of half, and this is equal to 0. This is equal to 0, students. Okay, and says yes, it is. So r square plus L square and whole to the power of 3 by 2. 3 by 2 means, and this into half, this into r square plus L square half, and this is equal to L square, 3L square, 3L square, and the R square plus L square, this is equal to half. So half and half cancel this one, and you can so that R square plus L square, this is equal to 3L square. So this is equal to R square equal to 2L square, or L square equal to R square by 2, and L equal to R by root 2. So where the electric field is maximum. So this is the ring and this is the L. Suppose this is the L. So L by root 2 is a position. L by root 2 is a position. R by root 2, sorry, R by root 2 is the position where the electrical field is maximum. Okay. So this is the position where the electrical field intensity is maximum. And what is the max value of this one? So you can easily show that if we substitute the value of this into this equation, so you can get Emax equal to 1 by 4 pi epsilon naught, and then QL, L equal to R by root 2. So R by root 2 divided by R square plus L equal to, so this is also R square by 2 whole to the power of 3 by 2 whole to the power of 3 by 2, and the value is 1 by 4 pi epsilon naught, and QR by root 2 by root 2, and then R square half 3 by 2. So this is 3 by 2 and this is R square. So this is 3 by 2 R square and whole to the power of 3 by 2 whole to the power 3 by 2. So this is 1 by 4, and here it is a root 2. Here it is a root 2, and this is 4 pi epsilon naught, and then QR divided by root 2. This is 3 by 2 whole to the power 3 by 2, and this is whole to the power of 3 by 2, and R square means 2 cancel, there is R cube. So R and R cancel this one, so you have to take a value of this one, calculate the value of this one, and this is 4 root 2 pi epsilon naught, and Q divided by this is 3 by 2 whole to the power 3 by 2, and then Q by R square, Is it clear or not? 1 by 4 root 2 pi epsilon naught 3 by 2 whole to the power 3 by 2 Q by R square, and you can show that this is 6 root 3. Okay, so this will be 6, this will be 6 root 3, so this is 1 by 6 root 3, and then Q by this one pi epsilon naught and R square. So Emax equal to this is the final result. So Q by 6 root 3 pi epsilon naught and then R square. This is the maximum value of this one. And the next part is so 3.9, a thin wire ring of radius is carries to find the magnitude and investigate then one and find the maximum strength of the magnitude and the corresponding distance L, and draw the approximate plot of the functions E. So the next and the final part, students, it is more important, because here at that particular concepts you have to know, you have to plot a graph of this one. So there is a concept, and the flux intensity, electrical field intensity. So if I say this is R by root 2, then you can easily say that the slope, and recently I completed Gauss's theorem, so it is repeatedly I say that flux. So it is electrical intensity. So electric field intensity due to the ring, since this is the center of the ring, then electrical field intensity the slope, this is the maximum value, so you can easily say that this is increasing. So this is increasing, and the function is, and what is about the nature of the slope? So it may be increasing in this way, or you can you can imagine that the electric field is increasing in that way. Why this is correct and this is wrong, students? First of all, think about this. Because this is correct, because the electrical field intensity increases, and if these the electrical field intensity increases in this way, then the electric field intensity somewhere it cannot be zero. It is increasing and increasing and increasing function. So since the electrical field intensity is somewhere zero, that is the infinity, so this is the concepts where the electrical field is increasing and it reaches a maximum value, and then again it will be like that, or it will be like, means it can reaches a particular point and then decreases like that. So there is a two possibility of this one. So this is the one number possibility and this is the second part. So electrical field intensity changes like that, or electrical field intensity changes like that, or it is exponential part like that. It may be. What is about the electrical field intensity? So for that particular questions, you have to integrate. If you take a slope of this one, that is the dE by dL, this is taken as a particular slope. Suppose you can take as a slope m1, then you have to integrate again with dm by dl again, and you can easily see that the electrical intensity is changing like that. So the graph of this one is first of all increasing in that way, and at a particular point it can changes at a particular point, and you can easily calculate this point also, and don't go for that particular details, just here it is say that draw the particular ones. So here you can integrate this one and calculate, and then easily calculate the value of r at that point. So you can easily calculate the value of length at that point where the electrical intensity is again changing, that is slope is changing in that way. So this is the actual graph, and again you can show for the negative part one, you can show here it is a maximum, so this is minus r by root 2, and this is the maximum value reaches, and again it increases in that way. In that way. So this is the nature of the graph, and I think students I properly explained that particular numericals. That is 3.9. And so as I say, is it possible? Then I do the next one, but I think it will be better. You can wait for the next excitement, that is 3.10. Okay, thank you.